Welcome to an exploration of one of the most profound questions in cosmology, the anthropic paradox. The universe appears remarkably fine-tuned for our existence. But is this a cosmic coincidence or something deeper? Let's begin with a puzzling observation about our universe. The fundamental constants of nature appear to be set with incredible precision, allowing complex structures and life to exist. Consider the gravitational constant, electromagnetic force, and cosmological constant. Each must fall within an incredibly narrow range. Change any of these constants by even a tiny fraction, and the universe becomes hostile to life as we know it. Let's examine just how precise this fine-tuning really is. The cosmological constant, which drives cosmic expansion, has a value around 10 to the negative 122 in Planck units. If this constant were just slightly larger, say 10 to the negative 120, the universe would expand too rapidly for galaxies to form. This is like balancing a pencil on its point. The allowed range is vanishingly small compared to what's theoretically possible. To put this in perspective, this precision is 1 part in 10 to the 122. That's a 1 followed by 122 zeros. How precise is that? Imagine you need to throw a dart and hit a target. The target is smaller than an atom, and it's somewhere in a circle the size of the observable universe. That's the level of precision we're talking about. Let's look at another example, the strong nuclear force. The strong nuclear force coupling constant is approximately 0.1176. If this constant were just 6% weaker, carbon couldn't form in stars. If it were 10% stronger, hydrogen would be unstable and all convert to helium immediately after the Big Bang. Without carbon, there's no organic chemistry. Without hydrogen, there's no water or organic molecules. Life becomes impossible. The weak nuclear force also shows remarkable fine-tuning. The Fermi constant, which characterizes the weak force, has this specific value. This constant determines how quickly neutrons decay into protons, which is crucial for nucleosynthesis in the early universe. If the weak force were stronger or weaker, the balance between neutrons and protons in the early universe would prevent the formation of heavy elements. This brings us to the central question. Why do all these constants have exactly the right values to allow life? Scientists have proposed several explanations for this fine-tuning. The first option is pure coincidence. We just got incredibly lucky, but the probability is so astronomically small that this explanation seems deeply unsatisfying to many scientists. The probability of getting all constants right by chance is less than 10 to the negative 100. The second option is that the universe was designed by an intelligent creator. While this is a valid philosophical position, it moves the question outside the realm of testable science. The third option is perhaps the most scientifically interesting, the multiverse hypothesis. The multiverse hypothesis suggests that there are countless universes, each with different physical constants. We exist in one that happens to allow life. If there are infinite universes, then even extremely unlikely combinations become inevitable somewhere. This is where the Anthropic Principle enters the picture. The Anthropic Principle comes in two versions, weak and strong. The weak Anthropic Principle simply states that we can only observe a universe compatible with our existence. This is almost a tautology. Of course, we find ourselves in a universe that permits observers. Universes without observers have no one to notice them. The strong Anthropic Principle makes a bolder claim. The universe must have properties that allow life to develop at some stage. This suggests that the existence of conscious observers is not accidental, but somehow necessary or built into the fabric of reality. Some interpretations take this even further, connecting to quantum mechanics. In quantum mechanics, the act of measurement or observation affects the state of a system. A quantum state in superposition collapses to a definite state upon measurement. Some interpretations suggest that observers play a fundamental role in actualizing reality from quantum possibilities. This leads to a provocative question. Could the existence of the universe somehow require observers? Physicist John Wheeler proposed the participatory anthropic principle. Wheeler suggested that observers are necessary participants in bringing the universe into being through a kind of cosmic feedback loop. In this view, observations in the present help determine the past, creating a self-consistent loop. While highly speculative, this idea is mathematically consistent with certain interpretations of quantum mechanics. Modern physics increasingly views information as fundamental to reality. Entropy, a measure of information, is given by Boltzmann's formula, S equals Kb times the natural log of omega. Here omega represents the number of possible microscopic configurations of a system. Information, encoded in bits, may be more fundamental than matter is. Shannon information is given by this formula, measuring the average information content. Some theorists suggest that consciousness emerges as the universe's way of processing information about it. Let's return to the probability question with more rigor. The probability of getting all fundamental constants right is the joint probability of each constant falling in its life-permitting range. Suppose each of the approximately 20 fundamental constants has a 1 in a billion chance of being in the right range. The total probability would be 1 in 10 to the 180th power. That's far more unlikely than finding a single atom in the observable universe. The life-permitting range is unimaginably tiny compared to all logical possibilities. The Anthropic Principle is fundamentally about selection effects. Selection effects systematically bias what we can observe. Because our existence is itself a filter, we can only find ourselves in the green circle, a universe that permits our existence, even if gray circles representing lifeless universes are far more common. The probability that we observe a life-permitting universe, given that we exist, is exactly 1. This is a certainty. However, this reasoning doesn't explain why life-permitting universes exist in the first place. The Anthropic Principle leads to other surprising predictions, like the doomsday argument. If we assume we're random observers among all humans who will ever live, we're probably somewhere in the middle of human history. This suggests the total number of humans who will ever live is roughly twice the number who have lived so far. About 100 billion humans have lived so far. This argument suggests maybe 200 billion total will ever live, which has sobering implications. This doomsday argument is highly controversial, but demonstrates how anthropic reasoning can lead to testable predictions. Can the Anthropic Principle make testable predictions? In 1987, physicist Steven Weinberg used anthropic reasoning to predict the cosmological constant's value. He argued it must be less than 10 to the negative 120 for galaxies to form, but not much smaller. The observed value, discovered in 1998, is about 1.3 times 10 to the negative 122, remarkably close to his anthropic prediction. This is considered one of the most successful predictions in cosmology, lending credibility to anthropic reasoning. Before we conclude, let's consider alternative explanations for fine-tuning. Perhaps a deeper, yet-to-be-discovered theory of everything will show that the constants must have their observed values. String theory once promised a unique solution, but instead found a landscape of 10 to the 500 possible universes. Another possibility is that constants evolve over time or vary across space. If constants evolve, they might naturally settle into life-permitting values in some regions, solving the fine-tuning problem. The anthropic paradox has deep philosophical implications. Does the universe have a purpose, or is purpose only something we project onto it? What counts as a satisfying scientific explanation? Is anthropic selection a real explanation or a philosophical cop-out? We face a circular puzzle. We exist because the universe permits our existence, and we observe a life-permitting universe because we exist. Perhaps some questions can never be answered from within the system, requiring an outside perspective we can never have. There's an intriguing connection to quantum measurement theory. In quantum mechanics, the universal wave function is a superposition of all possible states. Some interpretations suggest that observation collapses the multiverse wave function into our specific experienced reality. Observation selects one branch from the many-branch tree of quantum possibilities. The density matrix transforms from a pure state containing all possibilities to a specific observed outcome. There's a fundamental limit to what we can know about the universe. The maximum information content is bounded by area divided by 4 times the Planck length squared, known as the holographic principle. For our observable universe, this limit is approximately 10 to the 120 bits of information. Think of the universe as having a finite number of pixels. We can never know more than this maximum information content. This means we may never be able to answer why the universe contains this specific information, rather than some other configuration. One radical possibility is that we're living in a simulation. If sufficiently advanced civilizations can simulate conscious beings in artificial universes, the probability we're in a simulation is the number of simulated universes divided by simulated universes plus one base reality. If there are many simulated realities for each base reality, the odds favor us being in a simulation. This would explain fine-tuning simply. The simulators intentionally chose parameters that allow complex life to emerge. However, this just pushes the question back. Who fine-tuned the simulator's universe? Perhaps we must accept that some questions may never have definitive answers. We're fundamentally limited to observing one universe from within. We can never step outside to see the full picture. We're like inhabitants of a single point in space-time, trying to understand the entire cosmos. Our perspective is inherently limited. The Anthropic Principle may be the best answer we can give. We observe what we observe because we couldn't observe anything else. In conclusion, the Anthropic paradox remains an intriguing puzzle. The universe appears remarkably fine-tuned for our existence, but the reason behind this fine-tuning remains unclear. We've explored several possible explanations, from pure luck to the multiverse hypothesis, but each has its limitations and controversies. Ultimately, the Anthropic paradox challenges our understanding of the universe and our place within it, forcing us to confront the limits of our knowledge and the complexity of existence.